Alright, hey Professor. So first off, I'm going to address you singularly throughout the video because I hope you are the only person to ever watch this video. And secondly, we're going to go over a few different reactions today, and we'll start off with the lithium aluminum hydride reaction, or reduction, with an ester. And this is lithium aluminum hydride right here. As you can see, it's a lithium spectator ion with a negatively charged aluminum connected to 4 hydrogens. And although the negative charge here is on the aluminum, these hydrogens are actually nucleophilic. So what they can do is attack this electrophilic carbon up here, and this carbon is electrophilic thanks to the net dipole moment with oxygen. And it'll kick off this pi bond, put it on the oxygen, and we'll have ourselves this intermediate right here. Now from here, we'll kick down the negative charge, reform that pi bond, and kick off the alkoxide, leaving us with an aldehyde. But the reaction is not over yet because the lithium aluminum hydride will strike again, kick off the pi bond onto the oxygen, and give us this compound right here. And from here we can't kick down the negative charge anymore, so we're going to protonate the oxygen, and that'll leave us with a primary alcohol. So that's one reaction done and dusted. Next we have a Grignard reaction with the same molecule as before, an ester. In this case, the nucleophile will be a negatively charged methyl group, and that'll attack our electrophilic carbon, kick off the pi bond, and that'll give us this hopefully familiar looking intermediate. And from there, we're going to do the same thing as before, kick off the negative charge, reform that pi bond, and then kick off the alkoxide. And this time, we'll form a ketone. Though you may have guessed it, the same reaction will happen again. The pi bond will get kicked off onto the oxygen, and will form this compound, which can then protonate itself, and finally give us a tertiary alcohol. Moving on, we have one more reaction to cover, and that is the nucleophilic acyl substitution with a negatively charged nucleophile. And so in this case, we're just going to have a ketone instead of an ester, and our nucleophile is going to do much the same thing as before. We're going to attack the electrophilic carbon, kick off the pi bond onto the oxygen, and that's going to leave us with this compound right here. Now from here, the oxygen can't really kick down its negative charge anymore, so all it can do is protonate itself, and that'll give us this compound right here. So a tertiary alcohol with a nucleophile attached. As you can tell, this is an addition reaction, and that'll be important in a moment when we discuss what happens when you do the same reaction on an acid halide. It can be an acid halide, so it doesn't have to be chloride, but I'm just using chloride here as an example. So same thing as before, the nucleophile will attack the electrophilic carbon, it'll kick off the pi bond, it'll make this intermediate this time. Except this time we can kick down the negative charge and kick off the chlorine, and that'll give us this carbonyl with our nucleophile attached. So essentially what happened here is a substitution reaction. So between these two reactions, they're pretty similar other than what we end up with. We end up with an addition here and a substitution here, and between all 4 reactions we can see that they're actually quite similar. In every case we end up with the reduction of either an ester or a ketone, and we're adding on or substituting different things. In these 2 reactions up here, we're adding 2 hydrogens for the lithium aluminum hydride. In this one we're adding 2 methyl groups. And down here we're either adding a nucleophile or we're substituting it with a nucleophile. And yeah, so far all these reactions are pretty similar. Aside from the reagents and the products, the mechanisms are mostly the same. It's a nucleophilic attack. There's some sort of unstable intermediate form that becomes stable, and either the reaction happens again or it doesn't. And voila.